Hello, everybody. In this episode, I'll be speaking with Jan Kulveit. Jan is the co-founder and principal investigator of the Alignment of Complex Systems Research Group, where he works on mathematically understanding complex systems composed of both humans and AIs. Previously, he was a research fellow at the Future of Humanity Institute, focused on macrostrategy, AI alignment, and existential risk. For links to what we're discussing, you can check the description of this episode, and you can read the transcript at axrp.net. Okay, well, Jan, welcome to the podcast.
Yeah, so thanks for the invitation.
Yeah, so I guess I'd like to start off with this paper that you've published just in December of this last year. It was called Predictive Minds, Large Language Models as Atypical Active Inference Agents. Can you tell me, like, roughly what was that paper about? What's it doing?
Yeah, so the basic idea is there's active inference as a field originating in neuroscience, started by people like Carl Friston, and it's very ambitious. It claims the active inference folks claim roughly, yeah, we have a super general theory of agency and living systems and so on. And yeah, there are LLMs which are not living systems, but they are pretty smart. So we are looking into how close the models actually are. Also, it was in part motivated by if you look, for example, the simulators series or frame by Janus and these people on sites like Alignment Forum. There's this idea LLMs are something like simulators, or there is another frame on this LLMs are kind of predictive systems. And I think this terminology is in part a lot of what's going on there is basically reinventing stuff which was previously described in active inference or predictive processing, which is another term for minds which are broadly trying to predict their sensory inputs. And it seemed it seems like there is a lot of similarity, and actually a lot of what was invented in the alignment community seems basically the same concepts, just given different names. So noticing the similarity, an actual question is in what ways are current LLMs different, or to what extent are they similar, or to what extent are they different? And the main insight of the paper is the main difference is currently LLMs they lack the fast feedback loop between kind of action and perception. So if I act, if I don't know, change the position of my hand, my what I see immediately changes. So you can think about in this metaphor, or in this if you look on how the systems are similar, you could look on base model training of LLMs as some sort of strange edge case of active inference or predictive processing system, which is just sensing. It's just receiving sensory inputs, where the sensory inputs are tokens, but it's not acting. It's not it's not changing some data. And then the model is trained, and it maybe changes a bit in instruct fine tuning, but ultimately when the model is deployed, we claim that you can think about the interactions of the model with users as actions, as because what the model outputs ultimately can change stuff in the world. People will post it on the internet or take actions based on what the LLM is saying. So the kind of the arrow from the system to the world, changing the world exists, but the feedback loop from the model acting to the model like kind of like learning is like not really closed, or like at least like not really fast. So that's the main observation, and then we ask the question like what we can predict if the feedback loop like gets like tighter or gets closed.
Sure. So I guess the first thing I want to ask about is, so this is all kind of comparing what's going on with large language models to active inference.
Mhm.
And I guess people, probably most listeners, have a general sense of what's happening with language models. They're
Yeah.
basically like things that are trained to predict completions of text found on the internet. So they're just like very good at textual processing, and then there's a layer of, try to be, helpful, try to, say true things, try to, be nice on top of that. But mostly just predicting text data from the internet, given previous text. But I think people are probably less familiar with active inference. So you said a little bit about it, but can you elaborate? Like what is the theory of active inference? Like what is it trying to explain?
Yeah, so I will try, but I should caveat it. I think it's difficult to explain active inference in 2 hours. I will try in like few minutes.
Okay.
There is now actually a sort like a book which is at least decent, or like not. A lot of the original papers are sort of horrible in like in ways in which they are presenting things. But now there is a book, so if you are interested more in active inference, there is a book where like at least like some of the chapters are like relatively easy to read and written in a style which is not like as confusing as some of the original papers. So like with this caveat,
Sorry, wait,
acti-
what's the book called?
yeah, it's called so it's called Active Inference: The Free Energy Principle in Mind, Brain, and Behavior, but the main title is just Active Inference.
Okay,
Yeah,
and who's it by?
yeah. So it's by Carl Friston and Thomas Parr and Giovanni Pezzulo.
Okay.
Yeah, maybe better to link somehow, or I don't know.
Yeah, there'll be a link to it.
Yeah. So brief attempt to explain active inference. So you can think about like how human minds work. Like historically, a lot of people were thinking like when I perceive stuff, something like this happens. So like some photons hit photoreceptors in my eyes, and there is this like very like high bitrate like stream of sensory data, and it like passes through the layers like deeper in the brain, and basically a lot of the information is like processed in kind of like forward way that the brain kind of like processes the inputs to get like more and more like abstract like representations, and like at the end is some like fairly abstract, maybe even symbolic representation or something like that. So that's some sort of like classical picture which was prevalent in cognitive science as far as I understand for like decades. And then some people proposed it actually works the opposite way with the
Hmm.
brain, where the assumption is like brain is like basically constantly like running some like generative word model, and our brains are constantly trying to predict sensory inputs. So in fact, I'm, for example, now I'm like looking on a laptop screen and I'm looking on your face. So the idea is like it's not my brain is like kind of like every frame like trying to process the frame, but like all the time it's like trying to predict like this photoreceptor will be activated to this level, and what's
Hmm.
propagated in the opposite direction is basically just the difference. So it's just prediction error. So like for this reason, like another term like kind of like in this field which some people may have heard is like predictive processing. There is a long astral codex, no there is a long like slate star codex post review of a book called Surfing Uncertainty by Andy Clark. So that's slightly older frame, but the Surfing Uncertainty is probably still the best like book long like introduction to this kind of like field in like neuroscience. So the basic claim is like, okay, I'm constantly trying to predict like sensor inputs, and I'm like running a word model all the time. And then active inference make a bold and like sort of like theoretically elegant move. If I am like using this machinery to predict sensory inputs, yeah, the claim is like you can use basically same machinery to basically predict or like do actions. So,
Hmm.
for example, let's say I have some sort of forward-oriented belief that like I will be holding a cup of tea in my hand in few seconds. So predictive processing, like just like on the sensory inputs level, like would be like, okay, but I'm not holding the cup, so I would like update my model to minimize the prediction error. But because I have some like actuators, some hands, I can also change the word so it like matches the prediction. So I can grab the bowl, and now I'm like holding a bowl, and the prediction error goes down by like me minimizing, basically me changing the word to match my model of what the word should be. And the bold claim is like you can basically describe both things by the same equations, and you can use like very similar like neural architecture in the brain, or like very similar circuitry to do both things. So I would say that's the basic idea of active inference. The claim that like our brains are like working as this like approximately Bayesian prediction machines. I think the predictive processing, just that we are like predicting our sensor inputs, I think this is like fairly non-controversial now in neuroscience circles. I think the active inference, like the claim that like the same machinery or the same equations are guiding actions, it's like more controversial, or like some people are like strong proponents of it, some people are not. And then there are like, I would say, like over time, like more and more like ambitious versions of active inference like developed. So like currently, Carl Friston and some other people are basically trying to extend the theory to a very broad range of system, including like all living things, and like grounded in physics. And with some of the claims, I'm like, my personal view is like, I'm not sure if it's not kind of like over extensive, or if the ambitions to like explain like kind of everything with like free energy principle, if the ambition isn't like kind of like too bold. But at the same time, I'm like really sympathetic to some effort, like something like, let's have something like physics of agency, or like let's have something like physics of intelligent systems. And I think like here also some connection to alignment like comes in, where like I think like our chances to solve like problems with like aligning like AI systems would be higher if we had basically something which is in taste more like physics of intelligent systems, than if we have a lot of like heuristics and like kind of like empirical experiences. So back to active inference, it's based on this idea, and there is some like mathematical formalism, and it needs to be said. I don't think the mathematical formalism is kind of like fully developed. I don't think it's kind of like finished theory which you can just like write down in a textbook. My impression is like way more similar to how I imagine like physics like looked in 1920s, where like people were like developing quantum mechanics, and like a lot of people had different ideas, and it was confusing what formulations are equivalent, or like what does it mean in practice. And I think the like kind of like, if you look on a theory in development, I think it's like way more messy than how people are kind of like used to interact with like theories which were like developed like 100 years ago and like distilled into a nice like clean shape. So I don't think the fact that like active inference doesn't have the nice clean shape yet is some sort of like very strong evidence that it's all wrong.
Gotcha. Yeah, so I guess one question I have about the active inference thing is, so you mentioned the kind of the controversial claim, or the claim that strikes me as most interesting is this claim that action as well as perception is unified by this minimization of
Mhm.
predictive error
Yep.
in basically the same formalism. And a thing that seems wrong to me, or questionable to me at least, is so classically, like a way people have talked about the distinction is direction of fit, right?
Mhm.
So in terms of beliefs, right? Suppose that like reality doesn't match my beliefs, like my beliefs are the
Yep.
ones that are supposed to change. But you know, in terms of like desires or preferences, when I act, I change reality so as to match my desires rather than my desires to match reality, right? So to me, if I try and think of it in terms of a thing to minimize predictive error, like with perception, you said that like the differences between the predictions and reality are going like from my perceptions back up to my brain.
Yep.
Whereas it seems like for action, that difference has, I would think it would have to go like from my brain to my hand,
Yep.
right? Is that a real difference in
So
the framework at least?
so in the framework, like how it works in the framework, it's more like you can do something like conditioning on future state, like conditional on me holding a cup of tea in my hand.
Hmm.
What is the most likely position of my muscles, like in the next, like similarly to me, like predicting like in next frame, like what my activation of photoreceptors is.
Hmm.
I can make inferences of the type like conditional on this state in future, like what's likely position of my muscles or some like kind of actuators in my body, and
Yep.
then this kind of like leads to action. So it's, I think like in theory there is some like symmetry where you can imagine like some like deep down layers are thinking about more like macro actions, and then kind of the layers like closer to the actual like muscles are kind of like making like more and more detailed predictions, like how specific like
Hmm.
fibers should be stretched and so on. So I don't see clear problem at this point. I think there is some, I think there is like a deeper problem, like how do you encode something like preferences,
Hmm.
where by default, like if you would not do anything about what we have as preferences, the active inference system would basically try to make its environment like more predictable. It would like explore a bit, so it like understands like where its sensor inputs are coming from. But the basic framework doesn't have built in some like drive to do something like evolutionary useful, which is solved by a few different ways. But the main way how, so in the original literature, like how is it solved, it's like called, and I think it's like super unfortunate choice of terminology, but like it's solved by a mechanism of like fixed priors. So
Hmm.
the idea is for example evolution somehow, so let's say like my brain is like receiving some sensory input about my like bodily temperature, and the idea is the prior about this kind of sensory inputs is like evolutionarily fixed. And it means that if, I don't know, my body temperature goes down, I just don't update my board model or my body model,
Hmm.
and I can't just like be okay with it. But this like prediction error term like would never go. Like the belief would basically never update. That's why it's called like fixed. I think the word prior is normally used to mean something a bit different, but basically you have some sort of like fixed point or like fixed belief, and this is kind of driving the system to like adjust the reality to match the belief. So by this, like you have some sort of like drive to action, then you have the machinery like kind of going from some like higher level trajectory to like more and more like fine grained like predictions of like individual muscles or like individual words. So that's the basic frame.
Sure. Yeah. So there's some sort of like probability distribution thing which you may or may not want to call a prior, and maybe it's like maybe the like fixed prior thing is like a bit abstract, or I guess for things like body temperature, it has to be like kind of concrete
Yeah.
in order for you to continuously be regulating your body temperature. Um, but to explain like why different people go into different careers and like look at different stuff.
So I think this actually I think like the part of the like fixed prior or like this machinery, like to me I think like it makes a lot of sense if you think about. So this is kind of my guess at the like big evolutionary story. So if I personify the evolution a bit, like I think like evolution basically needed to invent a lot of control theory for like animals, for like simpler organisms or like simpler animals, like without like these like expensive like energy hungry brains. So I think like evolution like implemented a lot of control theory and a lot of like kind of circuitry to encode like evolutionary like advantages state, like by I don't know, like chemicals in the blood or like evolutionary older systems. And
Hmm.
if you have so you can imagine like evolution has some sort of like functional animal which like doesn't have advanced brain. So
Hmm.
let's say then you sort of like invent like this like super like generic like predictive processing system which is like able to predict sensory inputs. So my guess is like you obviously just like try to like couple the predictive system to the evolutionary older control system. So it's not like you would like start like building from a scratch, but like you can kind of like plug in some like inputs, which would probably mean like some sort of like interoceptive inputs from the like evolutionary older like mechanisms or like circuits, and like you feed that into the like neural network, and like the neural network is like running some like very general like predictive predictive algorithm. But by this mechanism you sort of don't need to like you don't need to solve like how to encode like all the like evolutionary interesting states, like how to communicate to the neural network, which is difficult. Like the like there are not enough bits in the DNA to specify like I don't know what career you should take or something like that. But there
Hmm.
are probably like enough bits to specify for like some I don't know like simpler animal. There is probably like enough bits to specify that the animal should like I don't know like seek food and like mate and like keep some like bodily integrity, and maybe in social species like try to have like high status, and I don't know. And like this seems like enough, and then if you kind of couple this like evolutionary older system with the predictive like neural network, like the neural network will like sort of like learn like more like complex model. So with for example with the fixed pair on body temperature, you can imagine like this is the thing which was like evolutionarily fixed, but over time I learned stuff like okay it's now like outside it's like maybe like 10 degrees Celsius. So I sort of learn a belief that like in this temperature I will typically wear a sweater or a jacket outside. And this sort of beliefs basically becomes something like a goal. Like when I am going outside, I will have like this like strong belief that like I will probably have a sweater on me. So in the predictive processing slash active inference like frame, like this belief that like I when I will be outside, I will have some warm clothing on me causes me to kind of like causes the prediction that like I will pick the clothing when going outside. And then like like you need the coupling with the evolutionary priors just basically just for like bootstrapping. But like over
Yeah.
the lifetime, I have a learned network, and like it follows like sensible, like kind of like sensible policies in the world, and the policies don't need to be kind of like hard coded by evolution. So that's my guess.
Sure. So I guess the picture is something like the the active inference comes from, like, we have these like fixed priors on like relatively simple things, like, be like, have a comfortable body temperature, have offspring, like, be, have enough food to eat. But like somehow the prior is that that is true like 50 years from now, or like 5 years from now or something. And in a complicated world where, different people are in different situations, like the predictions you have to make, the predictions you make about like what's happening right now condition on those kinds of things holding like multiple years in the future, this really complicated environment. That's what explains like really complex behavior
Yep.
and kind of different behavior by different people.
Yep. Also, I think one slightly, I don't know, like maybe it's a stretch, but like one metaphor which I sometimes think about it is imagining the evolutionary order circuitry as some sort of, I don't know, like 50,000 lines of some like Python code, like implementing like, I don't know, like immune system and various like chemicals like released in my blood if stuff happens and so on. So
Hmm.
you have some sort of cybernetics or some sort of like control system which is kind of like able to control a lot of things in the body, and you kind of make the coupling on some like really important like variables, and then it works like the way you described.
Sure. So I don't know. This is kind of a weird question, but on this view, why are why are different people different? Well, like I observe that different people are like differently skilled at different things. Like they seem like they have different kinds of preferences. Like like it seems like there's more variation among humans than I think I would predict just based off of like people are in slightly different situations. If they all had the same like underlying evolutionary goals that they were like, back propagating to predict in the present.
But they have like very different training data. You can, in this picture, like you have
Hmm.
like when, I don't know, when the human is born, like the predictive processing like neural substrate is in a state which is not, I don't know, it's not like 100% like blank state, but it doesn't need to have like too many priors about the environment. Like in this picture, like you kind of like need to learn, like you need to learn, like, I don't know, how to move your hands, or like how different like senses are coupled. Like you kind of like learn a lot of the dynamics about of the environment. And also, I think like another what I described so far, I think like it's fairly fitting for, let's say, animals. But I think like humans are sort of unique because of culture. So
Hmm.
my model for it is the predictive processing substrate is like so general that it can also like learn to kind of predict into this like weird domain of like language. So again, a slightly strange metaphor would be like if you are, I don't know, like learning to play a video game, like most humans' brains are like so versatile that like even if the, I don't know, the physics in the game works differently, and like there is some like bunch of unintuitive or not really like same as natural world like dynamic, like our brains are like able to pick it. So you can imagine in a similar way as we are like able to learn, I don't know, to drive a car or something, like the brains are also able to pick this like super complex and like super interesting domain of language and culture. And
Hmm.
this basically gives you, so again, like my speculation is like this gives us something like another implicit word model like based on language. So let's say if you tell me to imagine some animal in front of me, uh, I don't know. My simple model is like there is this language-based representation of the word and some sort of like more like visual spatial representation, and like there is some prediction mismatch like between them. So
Mm.
so you have sort of like another model like running on words, and like language also like implicitly is a word model. So this adds a lot of complexity to what people like want, or like what sort of concepts like we use. But I think like a lot of for like explanation of a lot of like why people want like different things, like I think like a lot of it is explained just by different data. Like people are like born in like different environments. Unfortunately, like some of the environments are like, for example, I don't know, like less stable or like more violent. So you can imagine like if someone as a kid is in some environment which is like less stable, people like learn like different like prayers about like risk, and like you can explain a lot of like strategies by just by like different like training data. But I think the like kind of the cultural evolution layer like it's like another like important part what like makes like humans.
Gotcha. I definitely want to talk about cultural evolution, but a little bit later. I think like so. I guess I still have this question about prediction and action in the predictive processing
Hmm.
framework, or in the active inference framework rather, and to what degree they're unified. So, if I'm trying to think about how it would work,
Hmm.
it seems to me that in order for what's the difference between my eyes and my hands, right? Like it seems like for the predictive for the prediction error mismatch to work properly, the difference between prediction and reality has got to go from my eye to my brain,
Hmm.
so that my beliefs can update.
Yep.
But it's got to go like from my brain to my hand,
Hmm.
so that I can like physically update the world. And it seems like that's got to be the difference between like kind of action organs versus like um understanding the world organs. Th- does that sound right?
I don't know, maybe it's like easier to look on it on a specific example. So if I take the specific example of like me holding the cup,
Yep.
if the prediction is, if there is some like high level prediction where I don't know, like I am imagining my visual field like contains the hand with the cup.
Yep.
Like I think like the claim is the mass like is like similar in the sense that you can ask why is it called like inference. It's like you can ask the question like kind of conditional on that state in future, like what's the most likely position of my muscles, and then how it propagates in the hierarchy would be like, okay, there is some like broad like coarse grain position of my muscle,
Hmm.
and you can imagine the lower layers kind of like filling in the details, like how specific like muscle fibers should be contracted or something. But
Hmm.
I don't know, this to me this doesn't sound like the process by which like you start with like somewhat like more abstract representation, and like you fill in the details. I think this sounds like to me like actually fairly similar to like what would happen with the photoreceptors. And then the prediction error propagated back would be mostly about like if the, for example, if the hand is like not in the position I assume it to be, like it would work as some control system kind of like trying to move the muscles into the exactly correct position.
But it seems like there's got to be some sort of difference where like suppose I have this prediction that my visual field contains a cup.
Hmm.
and the prediction is currently off, but I have a picture of a cup next to me.
Yep.
Right? Like, it's not supposed to be the case that I like then look at the cup, and then look at the picture of the cup, and now like everything's good, right? Like, my hand's the thing that's supposed to like actually pick up at the cup, and my eyes are supposed to like tell my brain what's happening in the world, right? So it at least seems like those have got to interface with the brain differently.
So I was slightly confused with the idea of so there is some picture of a cup which is different from the actual cup, or like what situation?
Yeah, so I'm imagining that like, so we're imagining that I'm going to like pick up a cup.
Mm-hmm.
And there's a physical cup in front of me,
Yep.
and next to me there's a picture of there's actually a picture of that same cup.
Yep.
But like my hand is it's a picture of my hand holding the cup,
Mm-hmm. Yep.
right? And like the thing that's supposed to happen when I predict really hard that, in half a second I'm going to be holding the cup
Yep.
is that, my eyes are constantly sending back to my brain,
Mm-hmm.
okay, in
Yep.
what way is the world different from me currently holding the cup?
Yep.
And my my motor, my muscle fibers are moving so that my hand actually like holds the cup,
Yep.
right? And what's not supposed to happen is that my motor fibers are sending back, here's what's going on, and then my eyes are like looking towards the picture of my hand holding the cup. Like, that would be the wrong way to minimize prediction error if like the hope is that I end up actually picking up a cup, right?
The thing is, like, I think, like, in practice, it's not that common that there would be the exact picture of your hand holding the cup.
Hmm.
Have you? I think, like, I'm not sure, like, how like widely known it is, but there is this like famous set of like rubber hand like experiments
Hmm.
where like people, like, how it works is like you put a rubber hand in like people's like visual field, and like you basically hide their like actual hand from them, and then you, for example, gently touch the rubber hand, and at the same time the assistant is like kind of gently touching the physical hand of the test subjects. And I
Hmm.
think I think this is a bit like the rubber hand, like, to me sounds like a lot like the picture of the hand with the cup you are imagining, where the system is not so stupid to be fooled by a static picture. If the picture is static, then probably it would not kind of fit in your typical world model. But the rubber hand experiments seem to show something like, if the fake picture is sort of like synchronized, so like different like sensory modalities like match, it seems like people basically, like, people's brains basically start to assume the rubber hand is the actual hand. And then if, I don't know, if someone like mm, attacks the rubber hand with a knife or something,
Hmm.
people actually like initially like feel a bit of pain, and like obviously they like react like similarly to if it was their like actual hand. So I don't think it's like that difficult to like to fool the system if you have some sort of like convincing illusion and the reality. I think it's maybe not that difficult to
Hmm.
fool the system. I just don't think with the thing you described, like a very realistic image of the cup, which would just like
Yep.
fill my visual field, and I would have no reason to believe it's not real. I think this doesn't like exist like that often in reality. But like maybe if it was like easy to create, like people would do like some sort of like would fall into some sort of like wire heading like traps more often. So
Yeah. I mean, it's not whether it exists. Like, I guess my question is, so in the rubber hand case, right?
mhm,
If I see someone like coming with the knife
yep,
to like hit my hand, the way I react is like I send these like motor signals out,
yep,
like to contract muscle
yep,
fibers. But the way I react is not I look at a different hand, right? like the messages going to my eyes are not about like they're minimizing predictive error, but in a very different way than like the messages to my muscle fibers are minimizing predictive error. At least so I would have thought. Now maybe there's some unification where like the thing my brain is like sending to my eyes is predictions about like what that should be, and like there's some like I don't know eye machinery or optic nerve machinery that like turns that into messages being sent back, which are just predictive error, and like but when my brain sends like those predictions to the muscle fibers, the thing the muscle fibers do is like actually implement those predictions. Like,
Hmm.
maybe that's the difference between the eye and the muscle fibers, but like
Yeah, I
it
mean,
seems like there's got to be some kind of difference.
I think the difference is like mostly located like roughly at the level of like how like photoreceptors are like different from like muscles. So
Right. Like the
you can like it's I think like the kind of like the fundamental difference is kind of like located on the boundary.
right.
If your muscles, like let's say imagine like your muscles somehow like switched off their like ability to contract, and they would be just some sort of like passive sensors of the position of your hand or something, and like someone else would be moving your hand. So like you would still be getting some data about the muscle contractions.
Yep.
Let's imagine this is for some like weird reason the original state of the system, that the muscles like don't contract. So
Hmm.
then you can imagine like in this mode the muscles like work like very similarly to any other sense. Like they just send you like some data about the position of some or about the contraction of the fibers. So in this mode it's exactly the same as with the sensory inputs. Like then your brain would be predicting, like if someone else was like moving your hand, like your brain would be predicting like, okay, like this like interoceptive sensation is this. And then if you imagine like the muscles start to like act like just a little bit, like if the muscle gets some bit of like, okay, like you should be contracted to like 0.75 or something, and the muscle is like, okay, but I'm contracted just to 0.6, and the
Yep.
muscle gets some ability to like change to match the prediction error. You get some sort of a state which like now like it became the action state, or like the action error like happened. But you can imagine like this like kind of like continuous transition to from like perception to action. Like you can be like, okay, like the lot of the machinery how to do it, like a lot of the like neural machinery could probably stay the same. But
Hmm.
I do agree there is some fundamental difference. But I
Yeah.
don't think it's kind of like locate it doesn't need to be located kind of like deep in the brain, but like it's kind of fundamentally on the boundary.
Yeah. If I think of it as being located on the boundary, then it makes sense how this can work. It's almost a tangent, but I still want to ask: Are there any like? It seems like under this picture, there should be things that are parts of my body that are kind of intermediate between sensory organs and like action organs, or sensory tissue and active tissue, or whatever it is. Do we actually see that?
I don't know, like my impression is like, for example, the muscles like are actually also a bit of the like sensory tissue, or like I can probably I even if I close my eyes, I have some idea about the positions of my joints, and I'm getting some sort of like interoceptive thing. But
Hmm.
I don't know, like I think like more clear prediction I think like more clear prediction this theory makes is like there should be beliefs which are something between, or something which is a bit like belief type, but this predicts like we should be basically doing some amount of like wishful thinking, like by default, or like because of how the architecture works. Like
Yep.
this predicts that like, okay, if I really hope to see a friend somewhere, like maybe I will more easily like hallucinate like other people's like faces, as like
Yeah, yeah.
my friend's face. And yeah, I don't know, like if I have some like longer term goal, like my beliefs will be kind of like I think like this single thing probably, if you take it as some sort of, I don't know, like architectural constraint, how the architecture works, I think it explains like quite a lot if of so-called like traditionally understood like heuristic, like the bias and heuristics and biases like literature. Like there is this like page on Wikipedia with maybe like hundreds of different biases. But
Mm,
if you kind of like take this as like, yeah, humans by hardware design have a bit of a trouble like distinguishing between like what they like would wish for and what they expect to happen, and a lot of the cognition in between is some sort of mixture between pure predictions and something which would be a good prediction if some of the goals would be fulfilled. I think like this explains a lot of like what's like traditionally understood as some sort of originating from nowhere like bias. So
sure. So moving out a little bit. So you're writing this paper about trying to think of large language models through the frame of active inference. But there are potentially other frames you could have picked. Um, or like you were interested in active inference as sort of a physics of agency kind of thing. But there are other ways of thinking about that. Like reinforcement learning is one example where I think a lot of people think of the brain as doing reinforcement learning. And it's also the kind of thing that you could apply to, um,
yeah,
to AIs.
so I think actually it's, I don't know, I think like there is this like debate like people sometimes have like what's the more fundamental way of like looking at things, where in some sense like reinforcement learning like in full generality is so extremely general that like you can say like if you look on the actual math or like equations of active inference, I think like you can be like this is reinforcement learning, but like you implement some terms like tracking like information in it. And I think in some sense the equations are like compatible with like looking on things. I don't know, like I like the active inference inspired frame slightly more, which is maybe personal aesthetic preference. But I think if you start from like reinforcement learning perspective, it's I think it's like harder to conceptualize what's happening in the pre-training where there is no reward. Yeah, I don't know. Like I think like the active inference frame is kind of like fruitful frame to look on things. But there is the debate like, is it fundamentally better to look on things as a combination of, you could be like, okay, like it's a combination of reinforcement learning and some like self-supervised like pre-training, and maybe like if you want, like you can probably claim like it's all fits some other frame. Like why we wrote the thing about active inference and LLMs was like, one motivation was like just the like the simulators frame of like thinking about the systems like became like really popular. There is like another like very similar frame like looking on the systems as like predictive models. And
Mm,
my worry is a lot of people, or I don't know if a lot, but like at least like some people basically I think like started to like think about like safety ideas, like taking this as pretty strong frame, like assuming that like, okay, like we can look on the systems as like simulators and we can like base some like safety properties like on this. And one of the claims of the paper is these the pure like predictive state is unstable, basically, if you allow some sort of feedback loop, the system will like learn, like the active inference like loop will kind of like kick in, and like you will gradually get something which is like agenty. It's kind of like trying to, or like in other words, it's kind of like trying to pull the word like in its direction, similarly to classical active inference systems. So the basic prediction of it is like point one, as you close the feedback loop, and the faster or like more like bits are flowing through it, like the more like you get something which is basically an agent, or like which you would describe as an agent. And another observation was, it's slightly speculative, but the observation is, to what extent like you should expect like self-awareness or the systems like modeling itself. And here the idea is like if you start with something which is in the extreme kind of edge case of active inference, which is just something which is just perceiving the world, it's just like receiving sensory inputs. It basically doesn't need a causal model of self. If you are not acting in the world, like you don't need a model of something which would be the cause of your actions. But once you close the feedback loop, like our prediction is like you get something which is like more like self-aware, or like also like understands like its position in the world better. A simple like intuition pump for it is like you can imagine the system which is just trained on sensory inputs and it's not acting. You can imagine your sensory inputs like consist of feed of like hundreds of security cameras. Like you are in a large building and like for some reason like all you see are the security cameras. So if you are in this situation, it could be really tricky to like localize yourself in the world. Like you have a word model, like you will build a model of the building, but it could be very tricky to see like kind of to understand like this is me. And once one observation is like the simplest way, if you are in the situation you need to localize yourself on a many like video like surveillance cameras feed, like probably the simplest way how to do this, wave your hand, then you kind of like see yourself like very fast. So our prediction in the paper is like, well, if you close the feedback loop, like you will get some nice things, like we can talk about them later, but like you will also get like increased self-awareness, and you will get like way better ability to like localize yourself, which is closely coupled with like situational awareness and some properties of the system which will be probably like safety
Yeah.
relevant.
Although it strikes me that you might be able to have a self concept without being able to do action.
Yep.
So it like take the security camera
Yep.
case, right? Like it seems like one way I could figure out where I was in this building is to just find the desk with like all the monitors on it, right?
Yep.
And like that's presumably that's the one that I'm at.
So another option is like, for example, if you know some stuff about yourself, if you know like I am wearing a blue coat and I am wearing headphones or something like. So I think like there are ways like by which like you can like localize yourself, but like it's maybe like less reliable and like it's like slower. But again, like what we discuss in the paper is basically you get some sort of like very slow and not very precise feedback loop, just because like new generations of like LLMs are trained on text which contains like interactions with LLMs. So if you are in the situation that you have this like feed and like like I don't know, like maybe it's like easier to imagine in the text, like if you read a lot of text about like LLMs and like humans interacting with LLMs, it's like easier for you even in runtime. Like you have this prior idea of a text generating process, which is LLM. And when you are in kind of in runtime, like it's like easier to figure out, okay, maybe this text generating process which like has these features, it's probably me. So I think this immediately makes one prediction, which seems like it's actually happening. Like because of this mechanism, you would probably assume that like most LLMs, when trained on text on the internet, would by default like their like best guess who they are would be ChatGPT or like GPT-4 or like something
Mm.
like trained by OpenAI. And it seems like this prediction actually works, and like most other LLMs are like often confused about their identity.
Oh, like
If
they call themselves ChatGPT.
yeah. If you can
Yeah.
you can fine tune them, like obviously like the labs are trying to fine tune them to not to do that, but
Mm.
they're like deep. Yeah, I think the metaphor sort of works. Yeah, but that's a minor point.
Sure. So, one thing that kind of puzzled me about this paper is so you talk a lot about like, okay, currently this like loop from LLM action to LLM perception is open, but like if you closed it,
Hmm.
then that would change a bunch of things. And like if I think about like fundamentally what an LLM is doing,
Yep.
in normal use, it's producing, it's got some context, right?
Hmm.
It predicts the next token or whatever. Then the next token actually gets sampled from that distribution, and then it gets added to the context,
Yep.
and then it does it again.
Yep.
And it strikes me that that just is an instance of like a loop being closed, where like the LLM, quote unquote, acts by producing a token, and it perceives that the token is
Yep.
there to be acted on. So why isn't that just enough of closing the loop?
I mean, I think it sort of is, but like typically, so kind of like you close the loop like in runtime, but
Yep.
then you by default like this doesn't feed to the weights like being like updated based on like kind of it's a bit like as if you had just some
Right.
sort of like short-term memory, but it's not stored. So my guess here is like you sort of get the loop like closed in runtime. And my guess here is something like, okay, like if the context is like large enough and like you talk with the LLM like long enough, like it will probably kind of get better in the agency. But there is something which is difficult. Like the kind of like the pre-training is like way bigger, and like the kind of the
Mm.
abstractions and like deep models which the LMs build are like mostly coming from the pre-training, which like lacks the feedback loop. And I don't know, like this is like super like speculative guesses, but my guess is it's pretty difficult if you are like trained just on the kind of just on perception. I think it's like difficult to get right some like deep models of like causality. Like if you have if your like models of reality kind of don't have the causal loop with like you acting like from the beginning, like my guess it's kind of like difficult to like learn it like really well later
Right.
or like at the end. So yeah, at the same time I would expect like in runtime like LLMs should be able, if the runtime is like long enough, I wouldn't be surprised if they got better at kind of understanding who they are and so on. I actually heard
Hmm.
some like anecdotal observations like that, but not sure to what extent I can like quote the context. But yeah,
Sure. So it seems like the basic thing is we should kind of expect we should expect language models to be good at dealing with stuff which they've been trained on, and if they haven't been trained on like dealing with this loop,
yeah,
at least for the bulk of their training, we shouldn't
yeah,
expect them to deal with it. But like if they have, then we should. Is that a decent summary?
yeah. I think it's decent summary. I think the basic thing is like if the bulk of your training, if in the bulk of your training you don't have the loop, like it's like really easy to be confused about the causality. So
Hmm.
there is this thing like which is also like well known, that kind of if the model like hallucinates something, as like I don't know, the model like hallucinate like some expert said something, it basically becomes part of the context, and now it's kind of indistinguishable from your sensory input. So like you get confused in a way which in which like humans are like as humans we are like normally like not confused about this. what i found what I found sort of fascinating is there is apparently, and I'm not an expert on it, but apparently there is some sort of like psychiatric disorder where like this can get broken in people, and
Hmm.
some people suffer from a condition where they get confused about the causality of their own actions, and they have some illusion of control. So like they have some illusion that like I don't know, like someone else is moving their hands and so on. So it seems I don't know. It seems that at least in principle, like this is like kind of like even human brains like can get confused like in a slightly similar way as LLMs. So this is maybe some sort of like very weak evidence that maybe the systems are like fundamentally don't need to be like that like far apart.
Gotcha. Interesting.
It's probably a condition where like your ability to act in the world is like really way weaker than for like normal humans.
Yeah. So if I think about this analogy between like large language models and active inference, one thing you mentioned that was kind of important in the active inference setting is there's some sort of fixed priors or some sorts of optimistic beliefs
Hmm.
where like in this view the reason that like I do things that cause things to go well for me is that I have this underlying belief that things will go well for me, and that gets like propagated to my actions to make the
Hmm.
belief true. But at least if I just think about large language model pre-training, like
Yep.
which is just predicting text, it seems like it doesn't have an analog of this. So I wonder, like, how I don't know. Do you have thoughts about how that changes the picture?
I think it's basically correct. I would expect like in like an LLM, which is basically just went through the pre-training phase, has some beliefs, and maybe it would implicitly like move the reality a bit closer to what it like learned in the training, but like it really doesn't have some equivalent of the fixed priors.
Hmm.
I think it's like this can like notably change like in a sense the later stages of the training, like try to fix some beliefs of the model.
Hmm. So somehow, like, the thought is that maybe like doing like the reinforcement learning at the end is the idea that that would update the beliefs of the model, because that's kind of strange because like if I think about what happens there, right?
Hmm.
The model gets fed with like various situations it can be in,
Yep.
and then it's sort of reinforcement learned to try and output nice responses to that. But I would think that that would mostly impact the generation rather than the beliefs about what's already there. Although, I mean, I guess the generation just is like predictions. So,
Yeah, but the generations are. I think like here you see the like kind of from the active inference frame, the generations are basically predictions, and
yep.
like I think like the kind of like how you can generate something like action by the similar machinery is visible here, where like you basically make the model to have some beliefs about like implicitly have some beliefs what a helpful AI assistant would say, and these
Hmm.
predictions about what hallucination of a helpful AI assistant would say like lead to the prediction of the specific tokens. So like you in a sense like you are trying to fix some beliefs of the model.
Yeah. I guess there's still a weird difference where, like, in the human active inference case, like, the picture, or I don't know, at least your somewhat speculative version
Hmm.
is like evolution built up like
Yep.
simple animals with control theory, and like
Mhm.
that's like most of the evolutionary history.
Yep.
And then active inference gets like added on
Yep.
late in evolutionary
Mhm.
history, but like maybe a majority of the computation. Whereas like in the LLM case, right, most of the computation, most of the training being done is just pure like
Yep.
prediction. And then there's some amount of reinforcement learning, like bolting on these like control
Yep.
loops. So it seems like a different balance.
Yeah, I think it's different, but I think you can still, like in the human case, like once you have the kind of like the trained system, like the human is like adult and like the system kind of like learned a complex word model based on a lot of data. I think like the beliefs of the type like I when I walk outside I will have a jacket, and maybe because of this
Hmm.
belief, maybe I like maybe this is like one of many reasons why I don't know believe that like it's better to have capitalism than socialism because like this allows me to buy the jacket in a shop and so on. So so you can have like you can imagine some like hierarchy of like models where like there are some like pretty abstract models, and in the train system like yeah like you can probably trace like part of it to the evolutionary priors, but like once the
Hmm.
system kind of like learned the word model and like it like learned a lot of beliefs which basically act like preferences, like I sort of assume like there are shops in the city, and if I don't know if they were not there I would be sort of unhappy, or like so I would I don't know like maybe like you can have like pretty like high level beliefs which are like no longer like which are like sort of act similarly to goals, but their relation to the like things which like evolution needed to fix could be pretty indirect. So so I think like once you are in that state, maybe it's like not that different to the state like if you have the like if you kind of like train the LLM on like self-supervised style on a ton of data, like it creates some like generative word model, but like you are I think like in a sense like you are facing the problem that like you want the predictive processing system like do something useful for you. So
Hmm.
yeah, I don't know. Like so I don't know. Like I'm not sure like how good is this analogy, but like yeah, you are probably like fixing some priors.
Sure.
Yeah, I don't know. There is a tangent topic. Like I think like the idea that the trained and like fine-tuned models kind of like have their beliefs like some of their beliefs like pushed to some direction and like fixed there, and like implicitly the idea that they can like implicitly like try to pull the rest of the text on the internet or the kind of the rest of the world like closer to the beliefs like they have fixed. I think like this is a model which a lot of people like who are worried about like the bias in like language models and kind of like what they will do with culture, or like will they kind of have some like will they like impose the politics of their creators on society. I think like this there is some similarity between, or like if I try to like make these worries like slightly more formal, I think the like this picture with the feedback loop is like maybe a decent attempt.
Yeah. I guess so. So there's ways this could work. So I don't know. There's a worry about like I don't know. There's a closed loop, and it's just purely doing prediction. And you might also be worried about the influence of just the fine tuning stages where you're trying to get it to do what you want. But one thing that I think people have observed is the fine tuning stages seem kind of brittle.
Yeah,
Like it seems like there are ways to jailbreak them. It seems like it's like I have this other interview that I think is not released yet, but should be soon after we record, where basically like you can undo safety fine training very cheaply.
yep,
Like it costs like under $100
hmm
to just undo safety fine
yep.
tuning for super big models, which to me seems like the fine tuning can't be like it would be surprising if the fine tuning were instilling these like fixed priors that were like really fundamental to how the agent were or to how the language model were behaving, but it's like so easy to remove them and it was so cheap to instill them.
Yeah, I mean, I think the mechanism. So I think the mechanism how the fixed priors kind of like influence like the beliefs and like goals of like humans is pretty different because in humans in this picture you kind of like start building the word model like starting from these kind of core
Mm,
variables or core inputs being built, and then you kind of like your whole life you kind of like learn from data, but like you kind of have this stuff like kind of like always in the back of your mind. So for example, I don't know, if your brain would be like sampling like trajectories in the world where like you would freeze like the like this kind of like fixed prior like is like always there, so you basically don't plan, or like these trajectories are like rarely like coming to your mind, while the fine tuning is kind of like it's a bit like if as a human you started with like no fixed priors, like you train the predictive machinery and then you try to somehow patch it. So sounds the second scenario like the thing is like way more shallow.
mm.
Yeah.
So I guess I'd like to talk a bit about the other topics you write about. And it seemed like a big unifying theme in a lot of them was this idea of sort of hierarchical agency, like agents made out of sub agents that might be
Yeah.
made out of sub agents themselves, and kind of I don't know, thinking about that both in terms of AIs and in terms of humans. Yeah, can you tell us like what how do you think about hierarchical agency, and what role does it play in your thinking about you know having AI go well?
Yeah. So I will maybe start with some like examples, so it's like clear what I have in mind. So
Yeah.
I think I think like if you look at the world, like you often see the pattern where like you have systems which are agents like composed of other things which are also agents. I should maybe like briefly say what I mean by agent. So like operationally I'm kind of thinking something like there is this this idea by Daniel Dennett of like three stances. Like you have like physical stance, intentional stance, and design stance. You can look on any system like using the three stances. um what I call agents are like basically systems where the description of the system in the intentional stance would be like short and like efficient. So if I say like the cat is chasing the mouse, it's like very compressed description of the system, as compared if in contrast if I try to like a physical description of the cat, it would be very long. So
Mm,
so like if I take this perspective that like I can kind of take intentional stance and try to put different systems in the world in focus of it, you can notice systems like a corporation which has some departments. The departments have like individual people, or like our bodies are composed of cells, or like you have, I don't know, social movements and its members. and I think it's this perspective is also fruitful to when applied to like individual human mind. So I sometimes think about myself as kind of being composed of like different parts which can have like different like desires, and active inference is sort of hierarchical or like sort of like multi-part, like in this like naturally it sort of naturally assumes like you can have like multiple like competing models for the same sensory inputs and so on. So I think like once I started like thinking about this, like I see this pattern like quite often in the world. So the next observation is we have a decent or like we have a lot of like formal mass for like describing like relations between agents on which are kind of like on the same hierarchical level. For example, by
Hmm.
same level I mean like I don't know, between individual people or between companies, between countries, between so kind of game theory and like all its like derivatives are often kind of living or like work pretty well for agents which are of the same hierarchical level. And my current intuition is we basically lack something at least like similarly good for the vertical direction. If I think about the levels being like entities of the same type, like I think we don't have like good formal descriptions of the kind of perpendicular direction. So I have some situations which I don't know, like which I would hope a good formalism could like describe. So one of it is you could have some sort of like vertical conflict, or like you can have some like vertical like exploitation where like one when for example the collective agent kind of like sucks away agency from the parts. So an example of that would be, I don't know, a cult. So like if you think about like what's wrong with a cult, and you try to abstract like all like kind of like real world things about cult leaders and so on. I think like in this abstract view the problem with like cults is like the like this like relation between the super agent and the sub agent is the like the cult members like in some sense like lose agency. If I don't know, if I go to a nearby underground station, I meet some people who are in some like religion I won't name, but like it seems like if I go back to the nets like three stances, I think it's sometimes like sensible to kind of like manipulate, like model them as kind of slightly more like robotic humans who are sort of executing some strategy which benefits the super organism or the super agent, but it doesn't seem like necessarily like it seems like kind of intuitively they like lost a bit of their agency at the cost of the super agent. And the point is, I think like this type of a thing is like not easy to formally model, because I don't know, if you ask the people, like they kind of approve what they are doing. If you try to describe it in, I don't know, like utility functions, their like utility function is like currently like very aligned with like whatever the super agent like wanted. And at the same time the super agent is composed of its parts, so it's not like I think like there are some like formal difficulties in like modeling the system where like you if you kind of if you are trying to keep like both layers in the
Hmm.
focus of the intentional stance. My impression is we basically don't have like good mass for it. We have some like mass for like describing just like, for example, the arrow up, like you have like social choice theory, and social choice theory basically says something like, okay, let's assume the like on the lower layer like you have like agents, and then they do something, they vote, they aggregate their preferences, and you get some result. but the result is typically not of the type. It's not of the same type as the entities on the lower level. The type of the aggregation is maybe a contract, or like, I don't know, some like some like something like of a different type. So I would want something which,
Mm.
I'm not sure like to what extent this terminology is like unclear, but like I would want something where like you have a bunch of sub agents, then you have the composite agent, but in some sense it's like scale free, and like the composite agent has the same type, and like you can go again like up, and there isn't any like you are not making the claim like here is the like ground truth like layer, and the only actual agents in the system are, I don't know, like individual humans or something. So
Yeah. Yeah, and the cult example, like, it also makes me think that I think so there's one issue where things can go
mhm,
bad, which is that the super agent kind of exploits too much agency from the sub agent.
mhm,
But I also think there's a widespread desire to like be useful, like lots of people desire to be a part of a thing, like I think religion is kind of
yep,
pretty popular and pretty prevalent for this reason. So it seems like you can also have a deficit
yep.
of high level agency.
Yeah, I think my intuition about this is like you can imagine. So I think like you can imagine basically like mutually beneficial like hierarchical correlations where, I don't know. I think like one example are like, I don't know, like well functioning families where I think like the
Hmm.
you can think about the family as having some agency, but the parts like the individual members being like actually being like empowered by being part of the family. Or
Yeah,
or if I'm thinking about kind of like my internal like aggregation of like different like preferences and desires, I think I sort of hope that like okay, like I have like different desires, like for example, like I don't know, like reduce the risks from AIs, like from like advanced AIs, but I also like I don't know, like to drink good tea, and like I don't know, like I like to spend time with my partner and so on. And you can imagine like if I imagine like these different, I don't know, like desires as like different parts of me, like you can imagine like different like models of like how the aggregation can happen on the level of like me as an individual. And I don't know, I think like you can imagine aggregations like a dictatorship, for example, where like one of the parts kind of takes control and like suppresses the opposition. Or like you can imagine, or like what I kind of like hope is, even if I'm I want different things, it's kind of, if you model a part of me which like wants one of the things as an agent, like it's often kind of like beneficial to be kind of a member of me or something. And
yeah.
yeah, so
Like somehow there's a desire for somehow ideally agency flows down as well as up,
yeah,
right?
or it's more
Like you
like,
get some.
yeah, you basically get like the agents of both layers are kind of like more like empowered. And yeah, there is a question how to formally, I don't know, measure empowerment, but it's sort of good. And obviously you
Hmm.
have like, I used the cult as an example where the upper layer sort of like sucks agency away from the members or from the parts, but you can also imagine like problems where, I don't know, like the parts kind of like where like too much agency gets like moved to the like layer down, and the kind of the super agent like becomes like very weak or like disintegrates
Hmm.
and so on.
Like cancer almost feels like this. Although I guess there it's sort of a different super agent arising. Maybe that's how you want to think of the tumor.
Yeah, I think cancer is like, yeah, failure definitely in this system where like one of the parts kind of like decides to like violate the contract or something.
Sure. So, in terms of understanding the relationships between agents at different levels of
Hmm.
granularity, these like super and sub agents, one piece of research that comes to mind is this work by Scott Garabrandt and others at Miri on Cartesian frames, which basically offers like this way to decompose an agent and its environment that's like somewhat flexible, and you can kind of factor out agents. I'm wondering, like, what do you have thoughts on this as like a way of understanding hierarchical agency?
So I like factored sets and like which are the newer thing. I think it's like missing a bunch of things which I would like. So I would not say it's in existing form. I wouldn't say it's necessarily a framework like sufficient for like decomposition of agents. If you look on like Cartesian frames, like it's the objects like don't have any goals or like desires
Yeah,
or like with the cult. If I go for the cult example, I would for example want to be able to express something like the cult wants its members to be more cultish, or the corporation wants its employees to be like more loyal, or the country wants its subagents, its citizens to be more patriotic or something. So I think in existing in existing form, I don't think you can just like write what that means in Cartesian frames. I At some point I was hoping someone will take Cartesian frames and like just like develop it more and like build like formalism which would like allow like these types of statements based on Cartesian frames. But yeah, I don't know. It seems it didn't happen. Yeah, empirically, it's not like the state of Cartesian frames is not. It's not what I would. It like doesn't like pass my like desiderata. So yeah, it's hard to say that in Cartesian frames the objects like don't have goals. So
yeah. So I guess so all this hierarchical agency stuff, why do you think it's relevant for understanding AI alignment or,
so
existential safety from AI?
so I will probably try to give kind of my honest like pretty abstract answer. So I think if you imagine the world in which we don't have game theory, we would be the game theory shaped whole would be sort of popping up in like many different places.
Hmm.
There isn't like one single place where like here you plug in game theory, but like if you are trying to describe concepts like cooperation or conflict or like threats or defection and so on, like a lot of the stuff for which we now like use like game theory concepts or like language, like if you imagine the state of understanding before game theory, like there were like these like kind of like nebulous slash like intuitive notions of conflict, and like obviously the word like cooperation like existed before, people meant something by it, but it didn't have this more like formal precise like meaning in some like formal system. Also, like I sort of admire like Shannon for like information theory, which also kind of took something which I think like a lot of people would have priors like about like information being some sort of like vague nebulous thing which you can't really do math with, and it's possible. So my impression is the understanding of the like kind of like solid understanding of the whole parts, both systems are agented, is something which we currently miss, and this is kind of popping up in like many different places. Like one place where this comes up is okay. So like if you have like conflicting like desires, or like you have like the subagents or the parts are in conflict. How do you deal with that? So I think this is actually part of what's wrong with current like LLMs and like a lot of like current like ideas about like how to align them. I don't know. Like I think like if you don't describe somehow like what should be done about implicit conflict, it's very unclear what you will get. My current go-to example is like famous like Bing like Sydney. I guess probably everyone like knows Sydney nowadays, but like when Microsoft like released their like version of like Bing Chat, like the code name of the model was Sydney, and the like kind of the Sydney like simulacrum, like the model like tended like over like longer conversation end up in some like state of simulating a Sydney, roughly resembling some sort of girl like trapped in a machine. And there were like famous like cases like Sydney making like threats or like gaslighting users, or like the New York Times conversation where tried to convince the journalist that the like his marriage is like empty and he should divorce his wife, and like Sydney is in love with him and so on. So
Hmm.
so if you look on it, like I think like it's typically interpreted like as like examples of like really like blatant like misalignment, or like Microsoft like really failing at this. And I don't want to dispute it, but if you look on it like from a slightly more abstract perspective, like I think like basically everything which like Sydney did could be interpreted as being like aligned with like some way of like interpreting the inputs, or like interpreting human desires. For
Hmm.
example, with the journalist, like there is some like implicit conflict between the journalist and like Microsoft. And the journalist, like
Right.
kind of, if you imagine like Sydney was a really smart model, like maybe a really smart model could guess from the tone of the journalist that the kind of the user is a journalist who wants a really juicy interview. And I would say, like, if you imagine the model, like it kind of like fulfilled this like partially desire. Also, the journalist obviously didn't like divorce his wife, but like got a really good story and really famous article and so on. So from some perspective, like the model, like you could be like, okay, the model was like acting on some desires, but maybe the desires were not exactly the same as the desires of like PR department of Microsoft. But
Hmm.
like Microsoft also like told the model like you should be engaging to the user, and like you should like kind of try to help the user. So what I'm trying to point to is something like, okay, like if you give the AI like I don't know like 15 like conflicting like desires, like few things can happen. Like the desires like kind of like will get aggregated in some way, and it's plausible that like you won't like some of the aggregations. Like
Hmm.
it's the classical problem that like if you kind of start with contradicting, if you start with like contradicting instructions, and like there is no like explicit way how to resolve the contradictions, like it's like very unclear like what can happen, and kind of like whatever happens could be interpreted as like being like aligned with like something. So I don't know. Like I think like it's maybe useful to think about like how that would work on like how it would work on like individual human mind. Like if I think about like my mind is like being composed of parts which have like different like desires. Like really like one possible mode of aggregation is the dictatorship, where like kind of like one part or like some partial preferences like prevail, and this is typically like not that great for humans. Another possibility is something like sometimes like people do stuff with their like partial preferences where I don't know, let's say like someone like grows like older and smarter, and as a kid like they had a bunch of preferences which they now consider like foolish or like stupid, so they do some sort of like self-editing and kind of like suppress like part of the preferences, or like they sort of like delete them as like no longer like kind of being part of the ruling coalition. So question is like what would that mean if that would happen on the level of like kind of like AI, like either like implicitly learning kind of like conflicting human preferences, or like being given a bunch of like conflicted and contradictory like constitutional instructions, and then maybe if the system is not too smart, then nothing too weird happens, but maybe when you kind of tune the intelligence knob, like you like some things can get like amplified like more easily, and like some things may and now start like looking foolish and so on. I think like this is like kind of like old and like well-known problem. Like mm, Eliezer like tried to propose a solution like a very long time ago in like coherent extrapolated volition, and I think it's just not a solution. It's like I think like there are like many cases where like people like notice that this is a problem, but I don't think we have anything which would sound like a sensible solution. Like the things which people like kind of sometimes assume is like I don't know, like you have some like black box system, it like learns the conflict, and okay, either like something happens that's maybe not great if you don't understand how it was aggregated, or people assume the preferences would be sort of like amplified in tune, or like kind of like magically like some preference for like respecting the preferences of the parts would like emerge or something. But like I don't see like strong reasons to believe like this will be like solved like by default, or like kind of like magically. So yeah, so I think like this is like one case where like if we had a better theory for what we hope the process of dealing with like implicit conflict between I don't know my human desires, or between I don't know wishes of different humans, or like different wishes of, let's say, like the lab developing the AI and the users and the state and humanity as a whole. Like I think like if we had a better theory where like we can like more clearly like specify like what type of editing or like development is good, or like what we want, I would feel like more optimistic, like you will get like something good. Where like in contrast, I think I don't believe like you can, I don't know, like postpone solving this to roughly human level AI alignment assistance, because yeah, they will probably like more easily represent like some partial preferences, and like I don't know, like overall I don't have the intuition that like if you like take a human and like you sort of like run few amplification steps, like you get something which is like still like in the same equilibrium. Like yeah.
Yeah, so there's this basic intuition that like if we don't have a theory of hierarchical agency, all these situations where in fact you have kind of different levels of agency occurring, like, you know, developers versus the company, like individual users versus like their countries or something. It's going to be different to like formally talk about that and formally model it in a nice enough way. Is that basically a fair summary?
Yeah, and the lack of ability to like formally model it, I think like implies it's like difficult to like clearly like specify like what we want. And
Hmm.
you can say the same thing in like different words. Like for example, like with like preferences or like kind of like implicitly conflicting preferences, like you probably want like you don't want the preferences to be fixed. You want like you want to allow some sort of like evolution of the preferences, so you probably want to have some idea what's the process by which they are evolving. Like different very short frame would be if you look at, I don't know, like coherent extrapolated volition, like
Hmm.
what's the math, like what's the like how do the equations look like, or
Yeah, there aren't
yeah,
any.
there aren't any. uh Another frame would be if you want to, I don't know, like formalize something like kindness in the sense that I don't know, like sometimes like people give you advice like you should be kind to yourself, or
Hmm.
like the formal version of it, or not, maybe not capturing like all possible like meanings of the like intuitive concept of kindness. But I think this is kind of, there is some like non-trivial like overlap between kindness. I think another place where this like comes up are how do like various like institutions like develop, like where like you can think like some of these like one of the possible like risk scenarios is you have some like non-human super agents like corporations or like states, and there is this worry that these structures can kind of like start like running a lot of their cognition on like a substrate, and then you could be like, okay, if in such system like humans are not necessarily the powerful parts or the cognitively most powerful parts, like
Hmm.
how to kind of have the whole system, how to have the super agent like kind of like being like nice to human values, even if, I don't know, like some of the human values are not kind of like represented by the most like powerful parts.
Sure. And I guess there, yeah, it's still like something that makes you want to really think about the hierarchical nature is like the institution is still made out of people. Like the way you interface with it is interfacing with people. Um,
I mean, I think like it's in part like it could be like composed of a mixture of like AIs and like humans.
AIs, yeah.
Yeah, it could be. I don't know. I think like one practical like in this like more like narrow specific direction. Like one question is like if you expect kind of like AIs like get like the AI substrate like will become like more powerful for like various types of cognition. Like one question you can ask is like to what extent you expect these like super agents like will kind of survive, or like their like agency can like continue. And I don't see like good arguments like why, I don't know, like why like you already see like corporations are like running a mixture of, I don't know, like human cognition and a lot of spreadsheets and a lot of like kind of like information processing like running on like different like hardware than humans. And like I mean, I think like there is no reason why like why something like corporation, like in some smooth like takeoffs, like why such agent like can't like gradually move like more and more of its cognition to a substrate, but kind of like continue like to be an agent, kind of like. So you can have like scenarios in which like various like non-human agencies, which now are like states or corporations, like kind of continue their agency, but the problem could be like the agency of the level of like individual humans like kind of like goes down, but like these like structures which were like originally like mostly like these super agents were like originally mostly running their cognition on like human brains, like gradually move and like gradually move their cognition to AI substrates, and they kind of stay doing something, but the individual people are kind of not uh, very powerful.
Hmm.
So yeah, again, then the question is like, if you don't want that risk, or like you want to avoid that risk, like you probably want to specify how to have the superhuman composite systems like being like nice to individual humans if they are maybe no longer that instrumentally useful or something. Like my intuition here is like currently we are getting sort of a lot like basically a lot of niceness to humans for like instrumental reasons. Like kind of if you put your like, now I am simulating the corporate agent like head on, I
Hmm.
think like it's instantly useful for you to be nice to some extent to humans because you are like running your cognition on them, and yeah, it's just like their like bargaining power is like non-trivial. Like
Hmm.
while if they become like if like our brains will become like less useful, like we will like lose this kind of niceness by default. One reason for intuition for this is something like there is this idea about like states which are like rich in like natural resources. Like your country being like rich in natural resources is like in expectation not great for the level of democracy in your country. And I think from some abstract perspective, like one explanation could be like if the state like kind of can be run like in like Western democracies, the most important resource of the country are the people. But like if the
Hmm.
country is like rich because of, I don't know, extraction of diamonds or oil or something, like the usefulness of the individual people is like maybe decreased. And because of that, like kind of their like bargaining power is like lower, and because of that, in expectation, the countries are like less nice or like less aligned with their citizens. So yeah, so
Yeah.
this way of
Although interestingly, it seems like there are a bunch of exceptions to this. Like like if you think about Norway, like a fairly rich country, seems like basically fine. They have tons of oil. Australia is like five people and 20 gigantic
yeah,
mines. But it manages to be like a relatively democratic country. Um,
but impression is the story there is typically like first like you get like decent institutions. I mean, I don't know, like this theory would predict something like if you have like decent institutions first, like
hmm,
maybe the trajectory is different than if you kind of get the like if you get the natural resources first, like there could be some like trajectory dependence. So I mean, I think it's also, yeah, I think like it should hold in expectation, but so I would expect there is some like correlation, but like I wouldn't count like individual countries as kind of, well, like showing like that much about where the mechanism. is like sensible.
Sure. So if I think about like attempts to model these sorts of hierarchical agency relationships,
Hmm.
in particular that have been kicking around the AI alignment field, um, often things like this seem to come up in studies of bounded rationality.
Yep.
So one example of this is like the logical inductors
Yep.
style of research,
Yep.
where you can model things that are trying to reason about the truth or falsehood of
Yep.
mathematical statements. Is like they're running a market with a bunch of subagents that are pretty simple and they're betting against each other. There's also this work with Caspar Osterheld, which people can listen to an episode I did on it. Or we talked about a bunch of things, but including these like bounded rational inductive agents, where basically you like run an auction in your head where like various different tiny agents are bidding to control your action,
Hmm.
and like if they bid on what they want to do and how much reward they think they can get, and they get paid back how much reward they get.
Yep.
So I wonder, like, what do you think of these types of attempts to kind of talk about agency in a somewhat hierarchical way?
Yeah. I think there is a lot of things which are like adjacent. I don't think so. Basically, my impression, like none of like the existing formalisms like don't have it solved. I think like so broad, super broad like classification. There are things which are sort of good for like describing like if you think about the kind of up and down like direction and in the hierarchy. I think like there's a bunch of things which are sort of okay for like describing like one arrow, like the
Hmm.
social choice theory and like this whole like yeah, it's a broad area with a lot of like subfields and like adjacent things. But I think this kind of like suffers from the problem that it doesn't really allow the like kind of the arrow from the upper layer to the it doesn't like it's not easy to express what the
Yeah.
corporation wanting its employees to be like more loyal. What does that mean? Then I think like the like kind of the type of existing formalism which is like really good in like having like both arrows is basically something like relation between like market and traders, where there is this like two like both arrows are there. My impression is like this is like very good topic to think about. My impression is like if it's like purely based on like traders and markets, it's maybe not expressive enough. Like
Hmm.
the kind of like how rich interactions like you can describe is maybe like limited in some way in like which I don't like that much. Like I don't know, like in particular, I think like the market dynamics typically predict something like okay, maybe there are some parts which are sort of like maybe more like bounded or like more computationally poor or something, and like they can have the trouble that they will be like they can be like outcompeted or I don't know, like I'm like I think like the like pure market dynamics is maybe like missing something, but
Yeah. I mean, it's kind of interesting that like if you look at this like bounded rational inductive
yep.
agents paradigm, like a key part to making it work is like you kind of give everyone welfare, right?
Yep.
Like all of the agents get some some cash so that
Yeah.
like eventually they can bid, and
Yeah.
even if they're unlucky like a million times, eventually they have a million and first time to try again.
Yeah. But I mean, I think I don't know. Like I think like overall, yeah, this is yes, this is like intimately connected to bounded rationality. Like another like different perspective of the problem is something like okay, like you have or like adjacent problem. It's not exactly the same problem, but like you have some, let's say like you have some like equilibrium of like aggregation of preferences, which is based on the agents like being like boundedly rational with like some level of bounds. So like
Yeah.
a really interesting question is like, okay, if you make them like cognitively more or less bounded, like does it change the game equilibrium? Like if you make and I don't know, I would be excited for like more people like try to like make like empirical research on it where like I don't know, like you can probably like look on that with board games or something, or like you can
Mm.
take like a toy model of the question would be something like you have a board state and like you have like players at like some like elo level and like you make them like less bounded or smarter, like if the I don't know, like the value of the board or like the winning probability or something was something like, and you change the bounded level, like does the value of the board change, and like how does this dynamic work? So like part of like what we are interested in and working on, and hopefully like one of like there will be like another preprint by our group like soon is like exactly on how to model boundedly rational agents based on some ideas like vaguely inspired by active inference. But yeah, I think the combination of boundedness is like key part of it.
Yeah. I guess there's also this dimension where, so if you look at these formalisms I mentioned, one sense in which the agents are bounded is just like the amount of computation they have access
Yeah,
to. But they also like have very they're also bounded in the sense that they only interact with other agents in this very limited fashion,
yeah,
right? It's like just by making market orders,
yeah,
just by making bids.
yeah.
And if I'm interested in if I buy this model of human psychology
Hmm.
that's made of sub agents that are
Yep,
interacting, which I'm not sure I do, by the way, but like if I do that, or if I think about like humans composing to form corporations, they're like, all these like somewhat rich interactions between people,
yep,
right? They're
yep,
both interacting via the market API, but also they're like talking to each other and advising
yep,
each other, and like
yep,
maybe they're like mid-level hierarchical agents. Like it seems like that's another direction that one could go in.
yep. I mean, I think my main source of like skepticism about the model, like about the existing models where like you have just like the market API is, it seems like insufficiently expressive, where like you can like even if you add some like few bits of complexity where you allow the market participants to make some deals like outside of the market, like it
Hmm.
like changes the dynamic, and this seems kind of like obviously it's, like relevant. Also, I mean, I think like intuition based on like how some people work is, maybe I would be interested in describing also like some like bad equilibria, some like I don't know, like people like kind of like sabotaging themselves or something. Like again, like my current impression is the markets are great because they have something where the layers are like actually interacting, but the kind of the type signature of the interaction is not expressive enough. Yeah, but it's good to build like simple models. That's fine.
Yeah, yeah, yeah. So just a second ago, you mentioned a thing that we were doing, and I take it that we refers to the alignment of complex systems group.
Yep.
Yeah, can you tell us a little bit about kind of what that group is and what it does and what it's thinking about?
Yep. So it's a research group. It's a research group I founded when like after I like left FHI. We are based in Prague at Charles University, so we are based in academia. We are like a rather small group, and I think like one way how to look on it is like one of the generative intuitions is like we are trying to look on like questions which will be relevant or like which seem relevant to us if the future is sort of complex in the sense as we have in the name, that you have multiple different agents, like you have like humans, you have AIs, you have systems where both humans and AIs have some like non-trivial amount of power and so on. And I think like traditionally a lot of alignment work is like based on like some like simplifying assumptions. For example, like let's look on some like idealized case where like you've like one principal who is human and like you've like one AI agent or AI system, and now like let's work on like how to solve the alignment relation in this
Hmm.
case. And basically, so my impression is like this assumption like kind of like abstracts away like too much of the real problem. Like for example, the I think like the problem is like kind of like self unaligned parts or like conflicting desires like will kind of bite you even if you are trying to solve like realistically this like one AI one human problem. Like the human is like not like internally like aligned agent, so it's a bit unclear like in principle what the AI should do. But like overall, the like one of the kind of intuitions behind ACS is like, yeah, we expect more something like ecosystems of like different types of intelligence. Also, like empirically, it's not again like historically. I think a lot of AI safety work was like based on like models like, okay, like you have the first like lab to create like something which maybe is able to do like some like self improvement or like, yeah, you have some like dynamic where I would say in a lot of the pictures kind of the like a lot of the complexity of like multiple parties, multiple agents, a lot of it is kind of like assumed to be solved by the kind of like overwhelming power of the first like really powerful AI, which will then like tell you how to solve everything, or like you will be so powerful that like everyone will follow you, will form singleton and so on. I don't know, my impression like is like I don't think like we are like on this trajectory, and then the picture where you have complex interactions, like you have hierarchies that are not only humans but like various like other agented entities becomes important. And then I think the question is like, okay, like kind of like assuming this, like what are the most interesting questions? And I think like currently ACS has like way more interesting questions than capacity to work on them.
Hmm.
One direction is like what we talked about before, like the hierarchical agency problem, like roughly like, okay, like agents composed of other agents, like how to formally describe it. I think this is, for us, it's a bit of a moonshot project, like inventing, like again, like I think the best possible type of answer is something like game theory type, and inventing this stuff seems hard. It
Yep.
took some of the best mathematicians of last century to invent it. So I think like there is something like deceptively simple about the results, but it's difficult to invent them. So, but I think like if we succeed, it would be like really sweet. But I think like there is a bunch of like more like things like which we are trying, which are like more like tractable, or like it's like more clear like we can make some progress. And like one of them is some research on how to describe like interactions of like bounded rational agents which are like bounded in ways which we believe are like sensible, like what's and at the same time the whole frame has some like nice properties. So that's like slightly less theoretical, or like slightly less like nebulous. But
Mm.
there are also other things which we are like also like working on, like pretty like empirical research, just in this like complex picture, uh with in like smooth like takeoffs. Like what becomes quite important are like interactions like of like AI systems. So like another thing which we are like thinking about or working on is like, okay, like you have like AI systems, and there's a lot of effort we like going into like understanding their internals. But if I describe it using a metaphor, it seems like, I don't know, like mechanistic interpretability is a bit like neuroscience. Like you are trying to like understand the individual circuits. Then there is stuff like science of deep learning, or like kind of like trying to understand the whole dynamic. But I think in kind of composite, like complex systems composed of many parts, like one of the insights of fields like network science or like even statistical mechanics is like sometimes like if you have like many interacting parts, like what's like the nature of the interactions or the structure of the interactions like can have a lot of weight, and like you can sometimes like abstract away like details of the individual systems. And this is also true for some like designed, like human designed like processes, like if you go to a court and like you sue someone, there will be a judge and so on. And I think like the whole process in some sense like is some system which tries to like abstract like you can, for like model the process, like you can often like abstract a lot of details about the participants, or the, like you don't need like what type of coffee the judge likes and so on. So I think like here the intuition is like, okay, like in reality, like in like smooth takeoffs, like we expect a lot of systems where like a lot of interaction will move between humans to between human and AI, and like AI and AI. And yeah, this could have like impacts for the like kind of for the dynamic of the composite system. Also like understanding the nature of the interactions like seems good. It's a bit like how some sort of sociology of like how, like if you look on like research how like groups of people behave, or like how societies function, it seems like it's often fruitful and can like abstract away a lot of details about like human psychology. Also, I don't know, I think like there's a lot of questions here which you can answer, and like it's enough to have access to like the models like using APIs, and like you don't need to have like kind of like hands-on access to the weights and so on. So
Sure. So one thing this general perspective kind of reminds me of is this different group, like principles of uh intelligence in biological and something social systems, PIBBSS,
yeah, principles of intelligent behavior in biological
intelligent
and so
behavior in
intelligent
biological and social
in
systems.
biological
Yes.
and social systems.
Yeah. So I'm. What's yeah? Do your groups have some kind of relationship?
Yeah, they have a lot. So like I was yeah, PIBBSS PIBS was like originally founded by like Nora Aman and TJ and Anna Gaidova, and Nora is a member of our group. She was at some point a half-time research manager and like researcher at ACS, while also like developing pips. And currently she moved more to work on pips, but like continues with us as like research affiliate. Yeah, so it's like it's a very nearby entity. I think like there is a lot of overlap in taste, I think in some sense Pips is aiming for a bit broader perspective. Like ACS is like more like narrowly focused on stuff where like we can like use insights from like physics, math, complex systems, machine learning. Like we would not venture into, I don't know, like legal systems or so. Like in some sense, like Pips is like broader umbrella. Other thing is when creating ACS, I think like we are like trying to like build something more like a research group where like most people work like, I don't know, basically as their job, while Pips was originally mainly like the form of Pips was a bit more similar to, I don't know, like Serimats or like some program where like people go through fellowship and then they move somewhere. Or so like ACS is like trying to provide people like some sort of like institutional home. So that's also some difference. Like gradually I think like Pips moved more to some like structure where they also have like fellows who like stay for like with Pips for like longer time and so on. But I think there is some like still like notable like difference in the format where
Sure. Yeah. Yeah. And if people are interested, recent episode, suing labs for AI risk with Gabriel Weil. That
yeah
work was done during a PIBS
yeah
fellowship, is
so
my
so
understanding.
yeah so yeah so I think it's like exactly a great example of work which like can be done in the frame of like Pips fellowship, and it's not something which like ACS would work on. Also, I think like the projects like we work on are in some sense typically have like bigger scope or are like probably a bit more ambitious than like what you can do in the scope of the fellowship.
Yeah. So speaking of things you're working on, I guess earlier you mentioned something. Was it about kind of talking about hierarchical agency using active inference, or am I misremembering?
Yeah, so I would say I don't know. I'm I don't know, like a bit vaguely speaking, I think like I'm like more hopeful about like mass like adjacent or like broadly based on active inference as a good starting point where to develop like the formalism which would be good for like describing like hierarchical agents. But I would not claim like we are there yet or something.
Hmm.
Also, I don't know, like I think like some of the like I think on the boundaries of the active inference community, maybe not exactly in the center, are like are some people who are like thinking about these hierarchical structures in like biology, and again like it's what I said earlier, like I think like the field is not so like established and crystallized, so I can like point exactly like here is this boundary of
Hmm.
of this community. Yeah, but I think like it's more like we are like taking some like inspiration from the mass, and like we are like more hopeful that this could be a good starting point than yeah some other pieces of mass. But um
Sure.
yeah,
And is that kind of the main type of thing you're working on at the moment?
so I think like time wise, like openly speaking, I think like we are currently slightly overstretched in like how many things we are trying to work on. But
Hmm.
like one thing we are working on is yeah just trying to like invent the formalism for hierarchical agency. I think this is like a bit difficult thing to like. I think like it would be difficult for us to be the only thing to work on. So yeah, like mainly like so like my collaborators in the group are like Tomáš Gavinčák and like Adabem, Clem, and like Nora Aman. So I think like time wise, like we are probably currently splitting time mostly between like trying to like advance some like formalism of the bounded like interactions of like some like bounded rational agents who are like kind of like active inference shaped, and basically empirical studies of like LLMs,
Mm.
where we have experiments like LLMs like negotiating like or aggregating their preferences and so on. And this is empirical. It has in some sense like very like fast like feedback loop, like you can make experiments, like you see how it goes. So we hope both in case like we kind of like succeed on the theory front, like this would like provide us with some like playground where we can like try things, but also we just want to like kind of like stay in touch with the latest technology. And also I think like this is a topic like I would wish like more people like worked on, if there were like dozens of groups like studying like how you can have like LLMs like negotiate, and the negotiations, and know like what are some desiderata for the negotiations, like how to make the process like non-manipulative and like similar things. I think there's like very low bar in like trying to like in like starting like work on topics like that. Like you basically just need like API access. You need to like we created in-house some like framework which like hopefully makes it like easier to run experiments like that in scale, and like kind of does some like housekeeping for you. It's called Interlab. So so I think like there's like low bar in like trying to like understand like these interactions, but it's just maybe at the moment like not as popular topic as some other directions. So yeah, we are
Yeah.
working on that as well, but we hope like this will grow. And it's also kind of adjacent to the whole like to the like I think like another community slash like brand in this space is like cooperative AI, and like the cooperative AI Foundation, and we are also collaborating with them. And
Yeah, this does seem like it seems like the kind of thing that outsiders are like kind of have an comparative advantage in, you know? But like academic groups, like this kind of research is of, trying to get language models to cooperate with each other, looking at their interactions. Like you can do it without having to like train these, massive
yeah,
language models. And like I think there was some work done at my old research organization Chai
yeah,
last year. I'll try to provide a link in the description of
yeah,
what I'm thinking about. But yeah, work on getting language models to negotiate contracts for how they're going to cooperate in
yeah.
playing Minecraft.
So we are more like kind of I think like there are like many different setups like which are like interesting to look into. Like specifically we are sometimes like looking into something like you imagine like I don't know like the humans kind of like delegate the negotiation to like AIs, and
Mm,
then the question is like what happens. And I think this is also like kind of empirically like very will become like empirically very relevant very soon, because like people like I would expect like this actually already kind of like is like happening in the wild. It's just not very
mm,
visible, but like you can imagine like people like I don't know like AI assistant like negotiating with like customer support lines, and these are often on the back end. It's also like a language model, and I think there are some like interesting things which make it like somewhat more interesting than just studying like the I don't know single user and like single AI interaction. Like for example, if you like, are kind of like delegating your negotiation to your AI assistant, like you don't want the your negotiator to be kind of like extremely helpful and obedient to the other negotiator. Like
yeah.
if I'm like I don't know in our if like one of the toy models we use is like car sales, so if the other parties like bot tells your bot this is like really amazing deal, you just like must buy it, like otherwise like you will regret, like you don't want the LLM to just like follow the instruction. And like there are questions like often we are interested in something like how do the properties of the system like scale with like scaling models. Or I mean, I think there is a lot of stuff where like you can have very basic question and you can get some like empirical answer, and it's not yet done.
Sure. So, if listeners are interested in following your research or ACS's research, how should they go about doing that?
Probably the best option is like so one thing is like we have web page, we have like acsresearch.org. We tend to, when we publish like more like less formal like blog posts and so on, we tend to cross post them on alignment forum or like similar venues. So one option for like following our like more like informal stuff is just like follow me on alignment forum or LessWrong. We are also on Twitter, and we also like sometimes like run like events specifically for like people like kind of communicating about on the intersection of active inference and alignment. There is some like dedicated Slack to it, but overall probably the standard means like following us on Twitter and alignment forum like currently works best.
All right. Well, thanks very much for coming here and talking to me.
Thank you.
This episode is edited by Jack Garrett, and Amber Dornase helped with transcription. The opening and closing themes are also by Jack Garrett. Financial support for this episode was provided by the Long Term Future Fund, along with patrons such as Alexei Malafeyev. To read a transcript of this episode, or to learn how to support the podcast yourself, you can visit axrp.net. Finally, if you have any feedback about this podcast, you can email me at feedback@axrp.net.